Good morning.
Good morning, sir.
So in just 2 minutes, we are going to start the session.
Oh my darling.
Aman Sheikh. Aman Sheikh. All of you, please mute yourself. Is it visible to you, the slide?
Yes, sir.
Okay. Okay, so let's start with the remaining topic of our fourth module, which we are going to complete today. There it is. Okay, yes. So see, last time we have seen the curvilinear motion. Okay. And we also made an attempt to derive the radius of curvature formula. Let me close it first. Okay. So where we were last time, that say there is a circular path like this. On this circular path, certain vehicle is moving, okay, with say some velocity v. Okay, so we come to know that this particular curvature has certain center. Okay, you can consider it as an arc of the circle. Okay, so that arc will have the center. So we define, after that we define the radius of the circular path, that is equal to rho. Okay, so we also discussed that when an object moves along a circular path, okay, it has an acceleration, a, okay, which can be resolved into two components. Okay, so this total acceleration will have two components. One is tangential component, okay, And another one is the normal component of acceleration, respectively. The direction of tangential component is along the direction of velocity. So if velocity, for example, at this particular point has this direction, okay, so in same direction the tangential component of acceleration will also be there. Okay, so here we will show that it is the direction of tangential component along the direction of velocity. Okay, and this tangential component, one can say that it is tangent to the particular point on the circular path. So if vehicle is here, you draw a tangent here, you will get the direction of velocity as well as the direction of tangential component. If your vehicle is, suppose here, if the vehicle is here at this point, so to know the direction of velocity, you will draw a tangent here like this, tangent to the curve. That tangent will show you the direction of velocity of the vehicle as well as the direction of tangential component of acceleration. So that is about the tangential component. We know that this tangential component can be calculated as rate of change of velocity. Okay, if suppose the velocity is changing at uniform rate, then we have other formulas, like when there is uniform acceleration, this particular equation will be useful to us. It is the equation of motion when acceleration is uniform. So it is final velocity, initial velocity, and time spent between initial and final velocity. It may happen that the velocity is not changing at constant rate. In that case, this acceleration component will be instantaneous. It will change instant to instant. Okay, so that is about the tangential component. Next is the normal component of acceleration. We know that normal component of acceleration is perpendicular to the tangential component. For example, say this is the direction of tangential component. So normal component will be perpendicular to tangential component. Always remember this. This is the fact. And if you draw that perpendicular will pass through the center of curvature. Okay, so this is the direction. This is the direction of the normal component. Okay, if suppose you are given that it is the direction of tangential component, one can find out the direction of normal component perpendicular to that, either left or right. Okay, it will depend on how is the curvature is. What to note here is that the angle between these two components is 90 degree. Okay, and also we got the formula for normal component, that normal component is equal to velocity ka square upon radius of curvature, v square upon rho. Rho is the radius of curvature. Okay, so it is the analysis when a particle moves along a curvilinear path. Its path is not the line, like a car which is moving on a straight road surface. So its motion is linear, it is moving in line. Okay, in that case there the normal component in that case is 0. Only what remains in that case? Only tangential component remains there. That is when a particle moves along a linear path, its total acceleration is just the tangential component and normal acceleration is 0. Okay. But when a particle moves along a circular path, that time it has two components, remember. Okay, one is tangential component, which is in the direction of velocity, and another one is normal component, which is perpendicular to that. If you want to find out, say, total acceleration, then one can easily find out the total acceleration from its components. We know that angle between them is 90 degrees, so I can vectorially add them. I can add like this, and I can also find out what will be the angle of this acceleration. Say alpha is equal to tan inverse of an upon at. So this alpha is measured with respect to tangential component. Okay, so suppose here if I show the total acceleration, then I will show it like this. It is my total acceleration, and this alpha is measured with respect to tangential component. So here I will show with respect to tangential component. Okay, so it will be, let me erase it. Okay, so this is the angle alpha. So any doubt in this? Yes, guys, any reply?
No, sir.
Okay.
No, sir.
Okay. So as far as we were analyzing the motion, okay, of the object along a curvilinear path, this formally come out, the formula of total acceleration and its angle. Suppose this is the circular path. I want to study the motion of the particle along in the xy plane. So I can decide my xy plane anywhere. Like I will select origin point here. Okay, and I will select two axes. One is x-axis and another one. This is
काय को चार्ज लेगा 3 महीने की गारंटी दिया है कुछ भी दिया वो बोल के गया है कि 3 महीने
okay. People take care of the mic. This is the y-axis and this is the x-axis. I am placing this curved path, okay, along this in this plane, xy plane. Now, obviously, if I place this path in the xy plane, any point on the curve will have some xy coordinate, x and y coordinate. Here I can have x and y coordinate. So say it is x1 and y1. When the particle will move forward, its coordinates will change. Okay, and by knowing the rate of change of coordinate, you can calculate the velocity in x direction. Velocity in x direction can be calculated as dx upon dt. Okay, and similarly you can also calculate the velocity in y direction. So velocity in y direction means at what velocity its y coordinate is changing. The particle is having x and y coordinates. So at what rate y coordinate means at what rate the particle is moving vertically. Okay. So that can be calculated with the help of taking derivation dy by dt. Okay. And once you have the velocity along x direction, along y direction, you can also have the acceleration. Acceleration in x direction ax is equal to rate of change of velocity in x direction upon time. Similarly, acceleration component in y direction can also be calculated as dvy upon dt. And once you know the components ax and ay, you can finally calculate what is the total acceleration then. So total acceleration will be vector addition. You know that x and y are the two mutually perpendicular axes. So vectorially we can add components of acceleration here ax square plus ay square. Ay square. And this acceleration which you have calculated here, this must be same as this acceleration. Only thing is that ये जो acceleration है, this acceleration we resolved along x and y axis. X and y axis. Or same acceleration if I will resolve in two directions, random two direction which are mutually perpendicular. Okay, so their formula is like this. If I have to show these components, so I will show like this. You know, the y-axis is vertical axis and x-axis is the horizontal axis, like this. And this total acceleration will be given like this. Its angle with respect to x-axis, say theta, you can calculate by formula tan theta. Tan theta is equal to ay upon ax. Okay, so actually what should happen, this a और this a का direction same आना चाहिए. देखो अगर this is the a, so how I will get ax and ay? Ax in this direction I will get and ay I will get in this direction. Actually इसका जो डायरेक्शन है, ये जो आपने एक्सेलरेशन कैलकुलेट किया यहाँ पे और यहाँ पे, दोनों का वैल्यू सेम है और डायरेक्शन भी सेम होगा. डायरेक्शन विल आल्सो बी सेम. ओके, ओनली थिंग इज दैट जो एक वेक्टर मिल रहा है आप उसको अलग अलग प्लेन में रिजॉल्व कर रहे हो. ओके, आई विल शो इट ऑन डिफरेंट स्लाइड. सपोज ये वेक्टर है आपका, ये ऐसा वेक्टर है. ओके, if somebody says me that sir resolve it along x and y axis, so what I will do, I will draw x axis horizontally. I know the direction of x axis and y axis is vertical, so say this angle will be theta. Okay, if somebody says that I want to resolve the same acceleration along two different directions. One direction is along the velocity. So suppose velocity का direction ये है. For example, suppose this is the direction of velocity. So I want acceleration in velocity का direction. Okay. So one component I will have here. which I will call as tangential component, and another component will be perpendicular to this. Okay, so this will be my normal component, and the angle between acceleration and tangential is alpha. So are you getting it? Same vector is there, vector same है, acceleration एक सिस्टम में हमने उसके कंपोनेंट्स लिए हैं इन टेंजेंशियल एंड नॉर्मल डायरेक्शन, एंड इन अनदर सिस्टम एक्स वाई का सिस्टम में along x axis and along y axis. So here we have the okay, and here ay. Are you getting it? Yes or no? Okay, so we will solve the examples and try to make things more clear. Okay, so I hope that you understand the two cases when an object moves along a line, that is translation or linear motion, and what is the difference between linear and curvilinear motion. So in curvilinear motion, you have two components of acceleration, which are those tangential and normal. Tangential component is along the direction of velocity, and normal component is along the direction of radius of the curvature path. Okay, so what I want you to note down this formula. You note down this formula, this text. It is summarized here. Take 2 minutes, note it down. Noted.
Yes, sir.
Sir.
If somebody wants me to wait, let me know. And next is yes, the formula of radius of curvature. Okay, that day we attempted to derive this formula for radius of curvature. Now it is your homework that you see this derivation, how it comes. Okay, so radius of curvature of the circular path. Okay, rho, you know, it is the circular path. The object is moving. It is the center of curvature. So this is your radius of curvature rho. So this rho can be found using this formula. Okay. So suppose if this curve we take in xy plane, x, y plane, then we can have coordinates of each and every point of the path, that is x, y. Okay, and if y is expressed as a function of x, okay, then these quantities can be found, dy by dx, like this. It is the mode of this term, and radius of curvature can be found using this equation. It can also be proved that radius of curvature is equal to this, where v is the velocity of the object, vx and vy are the two components of velocity along x and y direction. Okay, so say if velocity is acting here like this, so same can be resolved into two components, one along the x-axis, vx, and another along the y-axis. So same is here, into acceleration along the y direction, So acceleration along the y direction is nothing but a rate of change of velocity along the y direction upon time, with respect to time. Similarly, ax can be found as a rate of change of horizontal component or x component of velocity with respect to time. So you calculate these terms which are there in the formula, and you can then go for calculation of radius of curvature here. So you also note it down, then we'll go to solve the numericals on this particular topic.
Sir,
Yes. Yes.
sir,
हाँ बोलो फर्नांडिस.
sir, that radius of curvature comes out to be dx by d theta, right?
dx by
Means dx by d theta is taken as the radius of curvature.
dx by d theta r. Yes, sir. Yes, correct. because you know that any section, right? Any section of the arc, say dx, we are considering very small arc. So length of the arc is equal to what? Arc is equal to radius multiplied by angle, right? Radius multiplied by angle. So say arc ka length is dx, radius of curvature is rho, and change in angle over change in length dx is d theta. Suppose ये जो curve है, हमने बहुत small curve consider किया है, तो वो it will be as good as line dx. ओके और ये कर्व सेंटर पे कितना एंगल बना रहा है? This that is d theta, and say rho is the radius of curvature, so we can say dx is equal to rho d theta. So it comes out that radius of curvature is dx upon d theta. So when you will study that derivation, okay, you will come to know this. That's why I have given you this derivation as a homework for you. Okay. All of you note down this formula of radius of curvature. Actually, there are two formulas. One, when y is given as, this formula to be used when y is given as function of x, and this formula to be used when you have the values of velocities and acceleration and their components available with you, or by any way you can calculate, then use this formula. Is it done? So this topic numericals are simple, as other topics are also simple. Few concepts you need to remember. Is it done? Please note it down. Is it done?
Yes, sir.
Yes, sir.
Okay. So let us try to solve. This numerical will solve later. Yes. Okay, so this is the numerical. We are going to solve next. I give you 5 minutes to note it down, think of its solution, start the solution. Okay, so I hope that many of you have started solving this. So first of all, how to know that it is the particle, this is the case of a, curvilinear motion. Okay, so I'm reading the numerical. A particle is moving in xy plane. Okay, so xy plane, it here x is the horizontal axis, y is the vertical axis. So particle is moving in xy plane. It can also move in the linear path, like along the line. Even then, we'll call the motion of particle to be a xy plane motion. Okay, and its position is defined. Its position is defined by, so r bar is known as position vector of the particle. You know that if certain point is there in xy plane, it is having the coordinates x and y, and you can define the position of this point by a position vector. Okay, so that vector will originate from the origin. This vector is known as r bar, and to define the r bar, we define it like this: r bar is equal to x coordinate and unit vector along the x direction. So it is r plus what is the y coordinate of the point, and j bar or j cap, whatever you want to use, you can use. So in same way, the position is given, and its position is given by this equation or this parameter. Next, it is asking what is radius of curvature when time is equal to 2 seconds. When time is equal to 2 seconds. So as it is asking us to find the radius of curvature, we will assume that the particle is moving in the circular path. And formula of radius of curvature you should know. So radius of curvature ka formula is what? Yes, it is. So see how it is given. It is given in two forms, dy by dx form. Okay. So this formula will be used when y is given as a function of x. So in our case, is it so? Is y mentioned as a function of x? देखो.
No.
Yes, no, it is not given like that. Here, if we compare, okay, if we compare this equation with this one, on comparing, we can write this is nothing but our x. So ax is equal to 3 by 2 t square, and y is equal to, this is 2 3 t cube. On comparing with position vector, we see x is equal to this, y is equal to this. So here y is not mentioned as a function of x. Okay, both x and y are the function of time. So we will be using the second formula of the radius of curvature, which is equal to, we have radius of curvature is equal to v cube. Okay, and here there is some product of x component of acceleration with velocity component in y direction minus acceleration component in y direction with velocity component in x direction. So whatever is the output of this, उसका mode लेना है, means positive value लेनी है, that will divide v cube like this. So let me see, the formula is correct, vx into ay minus vy into x. Okay, so this mode will be same if I have changed the terms here and there, but value will be same because we are taking the mode positive value. Okay, so see now we have to calculate this parameter velocity, means it is the total velocity. Total velocity you can find by adding the components, that is equal to velocity का component in x square plus velocity component in y square. This equation we have. Then how we can find other components? What else we have to find? We have to find ax vy. So ax can be calculated as derivative change, rate of change of velocity in x direction upon time. This can be calculated. How to calculate vy? Vy you can calculate velocity in y direction is nothing but rate of change of y coordinate with respect to time, dy by dt. So y ka formula is here. You can easily calculate dy by dt. dy by dt will be 3 will come here, 2t square will come like that. What else is there? Ay. So ay ka value will be ay, sorry, yes, ay value will be rate of change of velocity in y direction upon time, and vx velocity in x direction will be rate of change of x coordinate upon with respect to time. So you see which one to calculate first. So
Sir,
yes,
why didn't we use the first formula for the radius of curvature?
you can use the first formula.
Only when it is a function of y is a function of x, right?
Here x and y are given. X and y are given as a function of time,
Mm.
right?
Yes.
So it will be better for us to use the second formula. Suppose अगर आपको दिया होता y equal to some function of x like say ax plus b, otherwise x square plus 1. So if y is expressed as some function of x, then it is easier to calculate these quantities dy by dx. आप dy by dx calculate कर सकते हो.
Okay, sir.
Okay.
Understood.
Even this particular example can also be solved using this formula. आपको just chain rule use करना होगा. Okay.
Okay.
So you see, now you decide कौन सा हमको पहले calculate करना है. You have to calculate radius of curvature. To calculate radius of curvature, we should know these 5 parameters. Total velocity ऐसे आएगा. Acceleration component along x, along y, velocity component along x, along y. These 5 you have to calculate. So you decide now okay, which one to calculate first. So here acceleration will come from velocity. So it will be better to find out velocity first. So I will find out velocity in x direction, velocity in y direction. Okay, let us calculate it first. Here it is given x is equal to 3 by 2 t square, right? We have to calculate what? Dx by dt. Dx by dt. So dx by dt, you just differentiate it. So it will be 3 by 2 into derivative of t squared 2t. It will come as 3t. And this dx by dt is nothing but your velocity. Velocity in x direction. Vx is equal to 3t. When we have to calculate the, this is the Vx. Okay. So I will write down Vx is equal to 3t. Say equation 1. Next you calculate velocity in y direction. It is nothing but dy by dt. What is the value of y? The value of y,
2 by 3 t cube.
2 by 3 t cube. Yes. 2 by 3 t cube. When you solve this, you see what you get. 2 by 3 into 3 t
2
square.
t square.
2t square.
So that gives me 2 t square. It is the velocity in y direction. Next, we have to calculate the acceleration. So acceleration in x direction is nothing but rate of change of velocity in x direction upon time. So d upon dt. What is the velocity in x direction? That is
3t.
from equation 1, 3t. So that is giving me the value of acceleration component in x direction as 3. Okay, means it is constant. Acceleration is constant in x direction. Say equation number 3. Next you go to calculate acceleration in y direction. So rate of change of velocity in y direction upon time. So it is d by dt. What is velocity in y direction? 2 t square. From equation 2, velocity in y direction is 2t square.
40 is the answer.
40, yes, correct. So you will find that acceleration in y direction is not constant. It is a function of time. Okay. So these 4 we have found. But we want all these quantities Vx, Vy, Ax and Ay at time equal to 2 seconds. When we have to calculate this, when time is equal to 2 seconds. So here you will write down that at t is equal to 2, at t is equal to 2 seconds, from equation 1, 2, 3 and 4. Okay. From equations 1, 2, 3 and 4. Put t ka value 2 in equation 1. So you will get velocity in x direction 3 into 2, that is 6 meter per second. Then velocity of y here 2t square. तो t का स्क्वायर 4 हो गया, 4 into 2 8. So velocity of y is 8 meter per, velocity in y direction is 8 meter per second. Acceleration in x direction is 3. तो t का वहां पे कुछ कंसर्न है ही नहीं, वो कांस्टेंट है, टाइम कुछ भी होने दो, 2 second 3 second. Acceleration in x direction is constant, so I will write down acceleration in x direction is 3 meter per second square, and acceleration in y direction, ये चौथा, acceleration in y direction is 4t. 4 into 2 is nothing but 8 meter per second square. So these 4 parameters we have calculated. Next is total velocity, resultant velocity. You know that resultant velocity is vx square plus okay, velocity in v square. So at time equal to 2, what is velocity in x direction? That is 6. That is 6 means 36 is 36 plus velocity in y direction is 8. So that is equal to 64. Iska square. It will give 100 and answer will be 10 meter per second. Now you know all these 5 parameters, you just go for calculating of radius of curvature. Did you get this example? Yes or no?
Yes, sir.
Yes, sir.
Okay. So you calculate and tell me the value of radius of curvature. Everyone, and if anybody is having any doubt, let me know that doubt.
41.66.
41.66. Okay.
41.67.
I will check. Yes, correct. It's 41.66. So if you concentrate what you have to calculate, what is available to him, like what formula is available to me, which are the parameters in those formula, where from the those parameters will come. Like this, if you make a systematic process, okay, you can solve it in easy steps. Uh, let me hear 5 voices, those who have completed.
Can you repeat the final answer?
Final answer is your 41.6 is correct answer is. It's correct. Pal, Shivam, any problem?
So can you scroll down?
Yes.
Units of
Thank you, sir. Done.
यूनिट क्या रहेगा सेंटीमीटर सर
So unit, you see what is unit given? It is given in second, and here it is not mentioned meter or centimeter. Okay, so we will use meter only.
सर कौन सा रेडियस पूछे नहीं रेडियस ऑफ कर्व
मीटर में 41.66 meter. Okay.
ओके सर
So if anyone wants me to wait, please let me know. Okay. Otherwise, we will go for next problem. So it is the similar problem. You solve it. Try to solve it. Similar problem is there. We will see the solution after 5 minutes. You try till then. Okay, guys. So let us try to solve this problem. So it reads a particle moves in xy plane and position its position is given by a position vector r. Okay, this equation is given, so I will write down what is given to me. Given is position vector r is equal to 3t I plus 4t minus 3t square j. Okay, on comparing this position vector with this, r bar is equal to xi bar plus y j bar. So from here we come to know that values of x lies like this 3t, that it is x is mentioned as a function of time and y is equal to 4t minus 3t square. So if you make a comparison of these two equations, you can write the equation for x and y coordinate like this. Okay. Further, it reads where r is the position vector of particle in meters at time seconds, at time t seconds. So units are given to us. Units are meter and second. These two units are given to us. So accordingly, velocity will come in meter per second, distance in meter, and acceleration will come in meter per second square. Okay. Find the radius of curvature of the path. Okay. And normal and tangential components of acceleration when it crosses x-axis again. When it crosses x-axis again. Okay. So to find, I will write down to find radius of curvature and components, that is normal component and tangential component. Okay. At specific time, t, when the particle crosses x-axis again. So we have to find out when the particle is on x-axis. Okay, you know, when particle is on x-axis, suppose it is xy coordinate. Suppose if particle is on x-axis, then you can say that at that time the y coordinate of the particle is 0, right? Suppose जो particle है, it is moving like this, ऐसे वो move कर रहा है. So उसने यहाँ पे cross किया and it again crosses the x-axis. So what is the time here? We have to find out. So we know that when particle is on x-axis, that time y coordinate is 0. Y coordinate is 0. Okay. So we will see where is the y coordinate. at x-axis, okay, y coordinate is equal to 0. That is, what is the equation of y here? 4t minus 3t square. 4t minus 3t square is equal to 0. Or one can write it like this: t equal to 4 minus 3t equal to t into 4 minus 3t equal to 0. So one can say either t equal to 0 or 4 minus 3t equal to 0. Okay. From here you will find that t is equal to 4 by 3, which comes as 1.33 second. Okay. So from looking at values of time, okay, when time was 0, at that time the particle was on x coordinate, okay, and when you put time equal to 0, at that time y is also equal to 0. So when x is equal to 0 and y equal to 0, particle was here, okay, and it is moving from here, and it is again crossing the x-axis at this point. So at this particular point, the time is now 1.33 second. Are you getting it?
Sir,
Yes.
Sir,
sir, are you going to take the extra lecture now?
Yes, we will continue. And I think in half an hour it will complete. So
then you have your lecture at
then
2 to 4 also.
2 to 4 Kartiki ma'am will take.
Sir, that means you are going to continue
Okay.
till 120.
नो नो नॉट 120. हाँ 120 तक तो जाएगा, लेकिन नहीं जाएगा उतना हमारा. ये एक न्यूमेरिकल ये है और उसके बाद और एक है,
Okay,
तो
sir.
तो हो जाएगा. वो लास्ट वाला तो बहुत सिंपल है.
Okay, sir.
अभी ये बताओ कि यहाँ तक आपको समझ में आया क्या? डिड यू गेट इट?
Sir, could you explain this once again? At
See,
X.
what we have to find: radius of curvature, normal component of acceleration, and tangential component of acceleration at a specific time, at time when the particle crosses the x-axis again. As देखो उसका wording देखो, when it crosses x-axis again. Okay, so initially it started when अगर वो x-axis पे है particle, it means what? It means y coordinate is 0. उसका y coordinate क्या है? 0 है. So that condition I put here at x-axis y equal to 0, and y का value is what? Y का value is given here, 4t minus 3t square. Okay, so from this equation we calculated whether either t equal to 0 or t equal to 4 by 3. Okay, so say once particle was on x-axis when time was 0. Okay, means at the start, and it will again come on x-axis when time will become 1.33 second. So we have to calculate all these three quantities when time is equal to 1.33 second. Got it?
Yes, sir.
Okay. So now rest is simple. अभी यहाँ से आप radius of curvature find out कर लो. What is the formula of radius of curvature? We have, we will write down. Okay, we have. What is the formula of radius of curvature? R is equal to velocity का cube upon ax vy minus ay vx, उसका मोड लेना है, ये डिफरेंस का मोड है. Even if it comes negative, we have to take the positive value out. So again, to find out the radius of curvature, you have to first find out the equation for vx, equation for vy, equation for ax, equation for ay, and total resultant velocity find out करना है. Same you can find out from this x and y coordinate. So if you differentiate x with respect to time, dx by dt will be vx. Okay, so x है, x से आप find out करो vx, vx से find out करो ax. ठीक है, y का वैल्यू दिया है तो y से आप फाइंड आउट कर सकते हो vy, velocity in y direction, and from there you can find out acceleration in y direction. Getting it? इतना तो फाइंड आउट करो, फिर देखते हैं हम नॉर्मल और टेंजेंशियल कंपोनेंट कैसे फाइंड आउट करना है. All of you find out. x का वैल्यू 3t है, vx is nothing but dx upon dt. vy का वैल्यू क्या है? v after velocity you can find out acceleration in x direction. Acceleration in x direction is rate of change of velocity in x direction. Similarly, y is there, so from y you find out velocity in y direction. And acceleration in this way you can find out. Resultant velocity is just the addition of vx and vy in vector form. Resultant velocity is vx का square plus vy का square. और सब इक्वेशन फाइंड आउट करने के बाद जस्ट पुट द वैल्यू ऑफ टाइम इक्वल टू 1.33 सेकेंड. तो ये टाइम का, इस टाइम पर आपको सबका वैल्यूज पता चल जाएगा. वेलोसिटी कितना है in x and y direction, acceleration in x and y direction you can find out, and then put all those values here in this equation of a radius of curvature. So you will know the value of radius of curvature, that is first parameter will be known to you. आप कैलकुलेट करो और मुझे बताओ कितना वैल्यू आ रहा है. So velocity in y direction, differentiate y with respect to t. 4 minus 3 into 2, 6,
4 minus 60.
correct? And acceleration in y direction, you differentiate velocity with respect to time. So this is 0 minus derivative of t is 1 minus 6. Okay. And we want these values. We want these values at time is equal to 1.33 second. So put the value of t equal to 1.33 here. So values will come as Vx. So Vx के formula में there is no t. So Vx का value will not change, will remain 3 only. Ax is 0. There is no t in the formula of Ax. So that is 0. Then velocity in y direction का formula, there is t in that formula. So put the value of t 1.33 and tell me what is the value of y component of velocity. 4 minus कितना हो जाएंगे?
-4.
Minus 4.
3.98
3.9 means minus 4, right?
minus 4.
Minus 4, right?
3.9.
Yes. And acceleration in y direction, उसके फॉर्मूले में तो t है ही नहीं. So direct value आएगा -6 constant. And apart from these values, we also need velocity, total velocity, resultant velocity. So you just add the components of velocity, Vx and Vy vectorially, Vx square plus Vy square, like this. So Vx का वैल्यू कितना है 3, Vy का वैल्यू है -4. कितना आंसर आएगा?
So 5.
5.
Yeah, correct. So that gives me 5 meter per second. So you can add units here. And all these values you keep in the formula of radius of curvature here. So radius of curvature at this particular instant when time is 1.33 second can be found.
Sir, is it 0.27?
So rho radius of curvature कितना आ रहा है आपका?
आ रहा है 0.277.
0.27. और वेट करते हैं हम आंसर्स के लिए.
So 6.94.
5.65 6.877
6.877. तो 6.877 आई थिंक रिपीट हुआ है, तो वो आंसर सही हो सकते हैं.
Sir, 6.944.
हाँ, 6.8 और 6.9 आर कमिंग क्लोजर. In book the answer given is 6.44 meter. Okay, so here you can highlight your answer. So everyone, have you come to this point, radius of curvature? Then we will see what else we have to find. Okay, say this is equation 1. put all this in equation 1. Okay. Okay, so let us concentrate then on the next point. Next point क्या find out करना है? Normal component and tangential component. Okay, we know that these two components, okay, these two components have the relationship like this, that total acceleration is equal to tangential component का square plus normal component square under root. Okay, so here you know that if we want to find out what we have to find out, normal component and tangential component. So say equation 2, we have the formula for normal component. Normal component is given by v square upon radius of curvature, right? It is the normal component of acceleration, is it? We have noted it down now here. कहाँ पे नोट किया हमने? This normal component of acceleration is v square upon rho. Okay. So where we are? So find out the normal component using this formula. कितना आंसर आ रहा है?
3.6.
3.6. Oh yes, correct. It is 3.6.
3.6.
And units, if you want to give, it will be meter per second square. Okay. And then tangential component can be found if you have the total acceleration. Okay, you know that total acceleration can also be written as okay, same acceleration can also be resolved along x-axis and along y-axis. यहाँ पे सेम एक्सेलरेशन है, लेकिन we resolve this acceleration in other direction. कौन कौन सा direction है? One is tangential direction in which the velocity is there, in which motion is happening, and one is the normal direction which is along the radius. Same vector, same acceleration vector we are resolving along x and y axis. Okay, so that you can find from these values. Ax is equal to 0 and ay value is -6. So if you put here, if you put these values here, you will see the value of acceleration is that is how much it will be, 0 square plus -6 का square and this whole thing under square root. So that will give me 6 meter per second. Okay. So this value of acceleration I will put in equation 2. Put into put this value in equation 2. So I will get 6 is equal to under root tangential value we have to find out. Okay. Plus normal value. Normal value is 3.6 square. So from here you can find out the tangential component. Now find out कितना हो रहा है.
4.8.
4.8 is the right answer. 4.8, and this acceleration is meter per second square unit. Meter per second square. So I think you have found all. You had to find normal component. You found tangential component. You found as well as the radius of curvature. Is it done? Okay, note it down. Is it done? Or you solve it? I will give you 3 minutes.
Done, sir.
Okay. So if anyone wants me to wait, please ask me, or we will solve the last numerical for this particular topic. You will have several number of examples in book. You can refer. Okay, so you pay attention on this. Take 5 minutes to think about it. Okay, so let us see the solution. Some of you might have solved it already. Okay, so you tally your answers. A car is moving on a curve of radius 300 meter. Curve of radius is nothing but radius of curvature. Okay, that is given that rho is equal to 300 meter. At a speed of the speed of the car is 90 kmph. Okay, so speed is nothing but your velocity v, 90 kilometer per hour. How to convert it into meter per second? What is the factor to be multiplied? To convert kilometer per hour into meter per second, which factor?
5 by
to be-
18.
5 by 18. So it is 5 by 18 meter per second. So 18 and 9, 5, 5, 25. 25 meter per second. The brakes are suddenly applied. Means at 90 kilometer per hour, brakes are suddenly applied, causing speed to decrease at a constant rate of 1.3 meter per second square. Okay, so it is the acceleration or retardation meter per second.
Retardation.
It is the retardation rate of change of velocity, rate of decrease of velocity. Okay, and again it is given as we also call retardation as negative acceleration. So whether this 1.3 meter per second square is tangential component or normal component. Sorry, tangential component or normal component. You know that when a particle moves along a curve, along a curvature, it will have two components of acceleration. One is tangential, one is normal. So this value of acceleration, which is negative acceleration, which is given to you, is tangential component or a normal component. कौन सा है ये?
Tangential.
Correct. It is a tangential component because it is due to rate of change of velocity, rate of change of magnitude, and the acceleration which arises due to change in direction of the particle is known as normal component. Okay, so it is the rate of change of value. So this given is the tangential component to you, that is equal to 1.3 meter per second square. As it is retardation, you can add negative sign here, minus 1.3 meter per second square. Determine the total acceleration immediately after brakes have been applied. Okay, so at the time of application of brakes, at that time the velocity was 25 meter per second. I have to find out total acceleration. So total acceleration, I know that if I know the components, if I know the tangential component and normal component, I can find out the total acceleration. So out of these two components, tangential component is given to you. Only thing which you need to calculate now is the normal component of acceleration. So normal component of acceleration का formula is given as velocity का square upon radius of curvature, and we have both of these parameters, velocity भी है, radius of curvature भी है यहाँ पे. So that will be velocity का square means square of 25 square upon 300. It is 25 square is 625 upon 300. Okay, you got the calculator. Tell me.
2.083.
0.08.
2.08, 2.08, 2.083 meter per second square. So now both the components are known to you, tangential as well as normal. You can find out the total acceleration in magnitude as well as in direction. So magnitude का formula is this. ये हो गया हमारा acceleration magnitude का formula, and direction of acceleration can be find out with respect to tangential component. So that is alpha is equal to tan inverse of normal upon tangential component. So it is the direction of total acceleration. Okay, if you will draw like this, अगर आपने ऐसे draw किया, if you show normal component in one direction and tangential component in another direction at perpendicular, okay, at 90 degree, it is say tangential. So this alpha is measured from which component? It is measured from the tangential component. So direction of total acceleration A will be measured from tangential component. You remember this, the alpha from where you have to measure the alpha? From tangential component. So use these two equations, then you got the answers for this particular problem. Okay. Tell me the answers, and after putting your attendance in chat box, you can then leave, or if you have any question you can ask.
2.45.
2.45 is here. So that's your answer, and then you have the angle also, alpha angle to calculate.
57.99 degree.
58.026.
I would say which one is correct. So yes, 58.03 is answer which is given in the book. It will vary depending on your calculation accuracy. Okay. 2.45 is very close, and here it is 57.9 is also close, no problem. Any doubt, anybody? So if you have given the attendance, then you can leave. I will keep this screen on for 2 minutes and then we'll stop sharing it.